Hello everyone, welcome to the channel. The purpose of this video is to show you why you should be attempting to use a GPU accelerated machine learning library versus one that runs solely on your CPU. So today we're going to look at the difference in a kNN classifier model where we use Scikit-Learn for the CPU model and Rapids AI or just Rapids, it's rapids.ai, but Rapids for the GPU model. So I want to just show you how easy it is to change up your code. Like there's really not much you need to do except for importing a couple different packages and so on. But the main purpose is to show you the time difference between doing the same code or the same model on the CPU versus the GPU. So I'll come down here and show you that right up front. So if you don't want to stick around, you don't have to. So right here on the GPU, we can see that it took about 3,500 seconds. So this is going to be right around an hour, just under an hour. Let's look at the actual time. I had it printed out. So yeah, this is just under an hour, with an hour being, I believe, 3,600 seconds is an hour. 60 minutes, 60 seconds, 3,600. And then over here on the CPU, it took about 50,000 seconds. So I'm not gonna try and do that in my head. Let's just do 50,000 divided by 3,600, 13.89 hours to run on the CPU, okay? So clearly, there's a massive speed up by using your GPU. Now, just so you can see that everything is pretty much the same, except for the only differences are where we call in the Rapids environment instead of using the Scikit-Learn environment. So up here, we're calling the train test split from the what's called CUML. This lives in the Rapids ecosystem. So this is their homepage, and right here, faster Scikit-Learn with QML, and then we're also calling the kneighbors classifier from QML, and then just regular matplotlib and glob and time and things like that. Now, also one thing I want to point out right up front is to go ahead and use call import GC, and you'll need to use that. Well, I don't know exactly when all you need to use it, but I use it pretty much every time after every cell. And the reason why I'm doing this is because if you don't call gc.collect after every cell, what you end up with is the RAM on your GPU being taken up, and it doesn't release the items stored in memory as you move along, as what normally happens in CPU-based Python, right? I'm sorry, the CPU-based machine learning stuff done in Python. So there's a lot more to that I haven't really familiarized myself with everything that's going on with this. But my understanding is that it dumps things that are not needed out of the GPU memory, and it frees up memory. So before when I was not using this gc.collect call, I was hitting 18, 19, 20 gigs of memory usage in my GPU, and then it was just bricking my code. It was just crashing, right? So I still have the run from this saved. It's still in the memory because I haven't closed this out yet. So we come in here, NVIDIA, oh, I spelled it wrong, duh. We come in here and we look at the stats for the GPU. So I'm running a 4090 with 24 gigs of memory, and this run, now it also has a little bit more in there right now because I'm also recording this using OBS. But if you come down here, you can see most of it was on this Python run with the Rapids virtual environment, okay? Now, what was happening was it would just store and it would build up. So for each iteration in this kNeighbors classifier run, it was just building up and not releasing. So that's why I added gc.collect in the run. So let me go back up here. I kind of got off track. So we're importing all of our necessary packages. And then this is my attempt to try and get it to spill over from the device memory, which is the GPU, onto the host memory, which is the system, the regular RAM, because I have 64 gigs of, I believe, 6,000 DDR5 in here. So I was trying to get it to spill over at a very low amount. That way I could get used to using that. So if I put my code on a cluster or something like that, but it wasn't working. So I just, commented it out and started using this gc.collect. So this was my attempt at first, and that wasn't working. I couldn't figure it out fast enough. So I went to this, as was suggested by some people on the Rapids Slack forum, Slack message board. So what am I doing here? And these are all your normal calls for Scikit-Learn, if you're just going to do it regular off the CPU. So what are we doing here? We are calling in all of the CSV files in this folder, in the data folder, which is here. There are 153 of them. Now, this is part of a homework assignment for my machine learning class. We only had to use 5 of these, so it didn't take that long using just 5. But I wanted to see what would happen if I used all 153, and then I wanted to see if I could port it over to the GPU. So that's why I ended up doing this. So it's calling all of the CSV files out of here, and it is concatenating them into one big data frame that it's going to train over and learn and test on. So that's what's happening here. Now coming down here, the reason why I created this mapping dictionary was because I was running into an issue on the GPU where it didn't like the fact that it was having strings. It needed numerical values, and I'm not going to get into that for this video. This is simply just to show you the time difference and how everything is pretty much the same except for the GPU calls, or the calls to the packages using the GPU. So let's keep going. I'm essentially showing you everything's the same. So another difference is that the GPU is using CUDA data frames. The Rapids page has more information about that. So if you want to look into that, you can go there and look into that. There's some things you have to keep in mind when doing this, and I think the strings in certain areas was a problem. But if you want more information on that, then I can rerun this and try to regenerate those errors for you and make a different video about that. Whereas this one, the CPU is just using pandas, right? So pandas data frames, CUDA data frames. As you can see, these data frames are essentially the same size. Now over here, this is dumping into the GPU memory, and this is on the system memory. So right there, that's 2.4 gigs on the GPU's VRAM, right? On the GPU's RAM. And then we're coming down here, and we are doing a single instance of kNeighbors classifier, and everything is the same. So the difference here is that on the CPU, I'm calling njobs equals -1, which invokes multi-threading wherever it's available. It may not always be helpful for you. It may not always speed up your code, depending on what type of model you're using. Generally, if it's available, I would assume that there's some type of speed up for multi-threading, but depending on your use case and what you're doing, it may not be beneficial. It's up to you. You need to figure that out for your code. So I'm doing one instance, and I'm doing my train test split here for the rest of the code. And as you can see, these are both the same. Everything's the same, right? And I'm getting pretty much the same score, right? 74.5 over here, 74.5 over here. And then I jump down into doing this iteration, this loop, which is where the timing comes in. The testing to see how long it takes on CPU versus GPU. So I'm creating dictionaries to send my accuracies to for plotting. I want to iterate from 1 neighbor up to 100 neighbors, and I want to keep track of the time between and the total time. And as you can see, everything is the same on each one of these. The only difference between these is that I gave these different names just because when I was looking at them, I was getting confused which one I was looking at, and I kept having to look up here at the file names, and it bothered me, so I gave them names to differentiate them. And I called this one CU kNN for CUDA kNN. But as you can see, it's the same, you're calling the same function here, right? And again, the only difference is njobs equals -1, because I wanted to give this one as much of a performance boost as I could by allowing it to multi-thread. And I'll show you what that looks like on the system resources once I get done going through all this stuff, because I'll have to rerun this, which will kill all of these outputs. So everything's the same. We're going through, we're iterating. We are defining the classifier. We are fitting it on the training data. And then we're getting the score for both the training data and the test data. So your accuracy should be higher on your train data because that's what it trained on. Doing the same thing over here. And then we are accounting for the elapsed time, time between, total time. We're appending all that to the list that I created before, and then just a simple print statement to let me know where it's at. Again, if I was running this on a cluster, for one, I wouldn't be using Jupyter notebooks. I would be using just a straight Python script. .py file, and I wouldn't have all these printouts because there's no point. So I test it out on my own personal machine, and then I can convert it over to run on a cluster if need be at a later time. And then so we come down here, we want to plot these accuracies, and it's pretty much the same thing. CUDA kNN accuracies, CPU kNN accuracies. Again, the training accuracy, as you can tell, is higher on both, as we expect. And then we keep going down, and this is going to be, we're doing a twin plot, so it's a dual Y scale for the times. So now this is interesting on the GPU. Maybe someone in the comments can explain why this is happening. I put a question on the Slack forum for Rapids. I haven't heard anything back yet, but that's, it's not their job to answer me all the time. It's, if someone can get back to me. If I do get an answer, I'll leave it in the comments. But interestingly, after 64 neighbors, the time almost dropped in half, right? So just over 40 to just over 20. So it almost cut it in half, probably did in some instances. And then it was a little bit faster, right? Obviously, because the time between cut in half. Whereas over here on the CPU, the time between up until, what is this, 1, 2, 3, 4, 5, 6, up until 7, it was jumping around between maybe 520 to 620 seconds in between each one, and then it settled down into 500. So maybe something is going on with the njobs. Maybe as soon as the neighbors get high enough, something happens which allows it to become more efficient. I don't know. I haven't looked into it. If you know why that's happening, let me know. I mean, we know that behind the scenes, it's looking for the k nearest neighbors, right? So it's taking a norm. It's doing a distance between all the neighbors, and it's finding the k closest ones, and it's saying, okay, based on these k closest ones, this is what we're going to classify this case as, and it's doing the same thing on the GPU, right? But why it's suddenly dipping here and then settling and then dipping here. So this is pretty much stable, and then it drops significantly, and then it remains somewhat stable again. And this is bouncing around, and all of a sudden it decides it wants to be stable. So that'd be interesting to look into. But again, the whole purpose of this is to show you how much of a speed up you can get if you can port your code over to using your GPU instead of your CPU. Now, this isn't just, I wouldn't call it a basic CPU. This is a Ryzen 7950X. So, yeah, Ryzen 7950X. We got 16 cores. It says the max clock speed is 5.88, but we know that's going to be single core. I think when I ran this CPU code on Windows, I was getting 5.2, maybe 5.3, maybe, if I recall. Again, this may vary depending on your setup, because I believe the 7950X, the clock speeds will keep going until you hit a certain temperature. Whereas in my previous Ryzen CPU, which was a 3950X, it reached the clock speed and then stopped, right? And my temperatures were always significantly lower. So there's a difference between the CPUs here. Anyways, that's a different topic. But my point, again, is time, right? So here the total time was just under an hour, and here the total time was just under 14 hours from the CPU. So less than an hour on the GPU, let's just call it an hour on the GPU, and then 14 hours on the CPU. Now, if you're having to run multiple instances of this, and the time it takes you to run it on your CPU, you could run 14 different instances on your GPU almost, right? Your time in between is significantly less, which is how you get your shorter time overall, obviously. So this is how simple it is. Like, all the code is pretty much the same all the way through, right? The only difference really is that I'm adding this gc.collect to, I think it's garbage collection is what it's called. Let's look it up. Here, let's use this AI assistant. What is gc.collect in Python? For those of y'all who don't use AI or anything like that to help with your code for whatever reason, man, you are missing out. This is amazing. It's like, let me have a little side rant here. So if you ever had a question about how to code something up or how to figure something out with your code, and you find yourself going to Stack Exchange or whatever, and you just can't, for some reason, you're not finding exactly what it is you're looking for, or whatever the problem is, right? You're just not finding, or not, I'm sorry, not Stack Exchange, Stack Overflow. I was thinking of Math Stack Exchange, Stack Overflow. And you can't exactly find what you're looking for in the exact use case, and you're still trying to figure it out, and you get stuck. And then you spend a lot of time, you post a question, and then you get somebody comes in and they say something like, oh, well, obviously blah. You should be able to figure it out from there. And it's like, come on, man, just woman, man, whoever you are, I'm asking for help. I took all this time to type this thing up, and you're just going to give me a one-liner like, well, obviously blah. And that's it. And then, and then somebody else comes in, they want to make an edit here so they can get cred or whatever. It's tiring, and I'm tired of like people jumping in to answer your questions with an ego to try and make, oh, you need to learn this. It's like, that's what I'm trying to do, man. Just give me the answer so I can figure it out. And then I'll figure out how much depth I need to go in to figure out what I'm trying to learn, right? So instead of dealing with all that, you just come over here into this AI assistant. Now this is, I don't know if this is ChatGPT on the back end or whatever, but this is Python Professional, and this is their AI Assistant Pro. And you just type a question in, and look, it gives you an answer. It doesn't give you a lecture. It doesn't try to get cred or points or anything. It just gives you an answer, and it's nice. And then you say, hey, I like this. I should probably read it first. Anyways, gc.collect is a method in Python's GC module that triggers a full garbage collection. It is a form of automatic memory management. It's a process by which programming language reclaims memory that was allocated to objects but is no longer needed. Nice. So I'm assuming that it says blah, 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 blah. Memory that was allocated to objects. So I'm guessing the GPU counts as an object because this thing automatically cleaned out my memory, right? So what I'll do is I'll remove this and then show you what's happening with my GPU memory. at the end of the video, which is coming soon, I promise. I'm not going to rant much longer. So anyways, that's what gc.collect is doing. Typically used to force a collection in order to free up more memory. So that's exactly what's happening over here. So it works with the GPU stuff as well, which is nice. So anyways, let's make this go away. Wait, hold on. Please note, Python's default garbage collector usually works well without manual intervention, and handling memory management manually could lead to less performant code. Therefore, you should only use gc.collect if you have a good reason to do so and you're sure about what you're doing. So I will show you the reason why I started doing this. All right. So the only difference here, before I went off on a side rant about Stack Overflow and whatever, is the only difference is this gc.collect, and that I had to implement this on the GPU side, and then I just copy and pasted it. Now I'm sure there's a much easier way to do this, but I was having a brain fog day and I said, screw it, I'm just gonna get it done because I got tired of dealing with trying to look up how to do it. And this was before I started using this AI assistant. So the only reason why I did it on the CPU is to make it identical to what's happening on the GPU. Okay, so everything's the same except for this gc.collect and then these import statements, right? So we're just importing certain things. So we're getting our train test split and our kneighbors classifier from QML over here, whereas here we're getting them from Scikit-Learn. And instead of pandas, we're using CUDA data frames, right? And then we're also importing garbage collection over here, okay? That's the only difference. So let me show you what happens without gc.collect on the GPU side. So we've looked at all this. I have these plots saved. Okay, cool. I just don't want to have to run it again. That's why I'm double checking. All right. So I'm going to comment this out. Comment this out. Comment. And this is usually where it failed. But if it failed here and then I tried to run it again, it'll fail much further up because it's not freeing up the memory on its own. Don't use it down here. Don't use it here either. Okay, so let me go ahead and restart. Now let's go ahead and let me pull this up over here. Make sure that we are back to low usage. So right here, we're at 3.62 gigs on the GPU. All right, cool. So let me move this right here so I can pull it back out. Dude, what am I doing? Oh, sorry. We're gonna run this. We don't need to run this. This is to pull everything in. Yes. And notice no garbage collection. Now this is the first place where we're gonna get a whole bunch of stuff. So let's see. So we're at 3.62 and now we're at 10.6. Just from importing our packages to this, we're at 10.6, right? And then we can see that Python, where are we at? Down here is using 7 gigs already. So let's do let me go ahead and just clear this. Let me restart this. And then we can get a line by line to see what's pulling in. So we're back down to 3.6. Packages are done. That's 1 gig. There's nothing here, but let's just see if a comment actually, nope. Let's see. So we were at 3.9. What was it before the comment? Oh, that's just, okay. That's just probably slight fluctuation from OBS. Okay, so reading in all the files is done, and these are CUDA data frames. So what probably happened is each one of these built up, and it stored each one of these files, and then it stored it into the overall larger file, and then each iteration of the files, right? So like the first one it stored, and the first and second one it stored those, and then maybe it stored the results of that, and then the first, second, and third it stored them again and the result of that. So that could be why this jumps up to 10.6 gigs, right? And then we come down here, mapping dict, and then we want to create the mapping and add it to the data frame. So then let's see, we are at 10.6, run that, and there's 2.4 gigs right there. And let's see what this jumps up by. Oh, didn't jump up. 0.1, that could be an OBS fluctuation. So not much, not much. So the initial data frame creation in CUDA was using CUDA was the big hog. So now we're gonna do the first run and also the creation of our train test using our train test split. So creating our training and testing data frames. So we're over here. We're gonna run that. And then okay, so we're at 10.7. And then once this completes, so I think in CPU, this one takes about 52 seconds, 54 seconds on the CPU. And then we'll see, I mean, we can look at it real quick because we can see what was holding. So it takes 24 on the GPU, and the last time I did it over here, it took 51 seconds. You can see right here. All right, so now we are at 10.7, and let's go ahead and see what we're at now. 17.75. So if you're not on a 4090, you're bricked. You've already bricked, like you would have been bricked right here. I think the 4080 is 16 gigs, I think. 4080 RAM. I think it's 16 gigs. Could be wrong. Let me see. How much RAM? Oh, the Super has 20. Okay, but the Super is relatively new. I think the 4080 only has 60. So, or 16. I'm sorry, 1.6. Okay. Anyways, now we're at 17, and this is our cap, right? So let's just see how far we can get before it crashes. And then as we're going here, let me run this. So 17 points, let's call it 17.7. Now we're at 20. We haven't even made it through one iteration yet for one neighbor. Still at 20. Okay, so it's holding. It's holding. Let's see what it does after it's completed. So this is going to be what? What did we see previously? About just under 50 seconds. So you guys come to this YouTube channel often? No. You should. Let me know what you want to see that it deals with this stuff, and I'll do what I can. So yeah, hey, it's a lot better. See, my my screen is getting glitchy because all of my RAM is being taken up. It's a lot better than oh, it's done. My bad. Here you go. Bad allocation. This is what I was getting initially before I was using gc.collect, right? I was getting this and I was like, man, what the hell? It made it through one, and then it started doing a second one. Let's see where we're at now. So we were at roughly 20, 17. So maybe it offloaded when it crashed, but now let's come back up here and let's do this. Let me rerun. So we are at, so if you don't know that that's what's happening and you're thinking you're just trying to fix something and you go to rerun stuff, let's see what it does. Because remember, it pulled in 10 gigs running this before, right? So let's see, we're at 17. Will this crash us? Yep, we're crashed. So it can't, it's done. It's bricked, right? But let me see if I just do gc.collect here. If I run that, I have no idea what that means. Maybe that's what it dumped down to. I don't know. Let's find out. It didn't clean up everything, so maybe you have to just restart because we're still at 17. So let's restart. So it didn't work just running it randomly up top. It's probably because these things, like all of these things are still saved down here, right? Like it goes in order, because you can bounce around and do stuff in a notebook. And sometimes that can be a disadvantage if you're not paying attention. But anyways, so we restarted. We're back down at 3.6. Cool. So we don't need to do this, but we'll just do it. I have no idea why that is doing that. I don't really care to dive into it right now. So just to see. Oh, my bad. That's why. I didn't rerun the first cell. All right, so let's see where we're at after importing 4 gigs. Let's see if this does anything initially off the import. No, not really. And then we're going to bring it back here. So remember, this took us up to 10 before. And let's see what it does now. It might still take us up there because it needs to hold all of these, this big data frame, right? But maybe all the ones in between it doesn't. So let's see. No, it still took us up there. Maybe it just really comes into play down here, because after we do this, we can essentially dump all of this stuff that it's holding for this run of kNN, and then each time we get done running kNN, it can just dump it, right? So that's what I'm thinking. If you know more than me, please educate me in the comments. Not like somebody on Stack Overflow, but like, you know, someone who just wants to educate people. So anyways, I hope that this has been helpful. Hope that you have been able to see that, you know, if you take a little bit of time to port your code over to using one of these GPU-enabled data science packages, it can be very, very useful and very helpful and help you reduce your computation time, right? Another thing is so I tried to set this up in Windows and I was having some issues, so I jumped into my Linux OS since I'm running a dual boot, and it was much easier for me to set up in Linux as a virtual environment. So if you're trying to set this up and you have issues, let me know and I can make a video. I can delete it off my system and then make a video of setting it back up again. But really, if you just go to the Rapids AI website, let's see here. I will show you. Will I show you? I'm trying to get this to let's see. Rapids AI. If you go to install, and if you follow, this is essentially what I did. I followed these instructions, and I came down here and I did stable, conda, CUDA 12, Python 3.10, standard. But then I said, no, let me just install everything so I don't have to do this anymore. Specific packages, and I just went doop 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 doop. Okay, installed all these, and I use this to install everything. Right, you can copy command, and you got it. Now, initially I had an issue; things wouldn't run, and then I just couldn't figure out why. And then I finally looked into the troubleshooting, and this will install all this stuff and Jupyter Lab, right here, but it won't install notebooks. Like Jupyter Notebooks doesn't get installed for some reason. I let the team know at Rapids. I'm not sure if they're gonna do something about it or what, but just remember, if you do all this and you're still getting some type of issue, try installing Jupyter Notebook separately and then see if it works, like separately into that environment. Because it's probably not being installed with this stuff, with these commands, and then see if that works. So if you want to make a video about doing that, installing all this, let me know. And it's going to be a video about installing it in Linux, not Windows. So if you're interested, let me know in the comments. If you want to see more of this machine learning stuff, I've been doing quite a bit of this for homeworks and midterms and everything for this machine learning class. We've done k-nearest neighbors classifier, k-means, we've done random forest, and we are getting ready to start doing some neural nets with multi-layer perceptrons. So if you want to see some of this code and have a little bit of it explained to you, so maybe you're having some issues or whatever, feel free to let me know in the comments, and I will do what I can to make a video for you about that. All right. Thanks for taking time to watch, and let me know what you want to see. All right. Bye.